Hi, I'm Bob. Welcome back to 5 Minute Econometrics. Today, we will explore an approach to alleviate the omitted variable bias. It is known as the Proxy variable method, or the plug-in solution to the omitted variable problem. We start with the true relationship model. The outcome variable y is related to x1, x2, and x3 star. However, we can only observe x1 and x2, and we do not have data on x3 star. If we omit x3 star from the model, this will introduce omitted variable bias. We do have data on another variable x3. We can treat x3 as a proxy variable for x3 star if they are correlated, as indicated by the proxy variable equation. We run the regression of y on x1, x2, and x3 and obtain the OLS estimators alpha 1 hat and alpha 2 hat. We can show that alpha 1 hat and alpha 2 hat are consistent estimators of the population parameters beta 1 and beta 2. This conclusion is based on the assumption that the error term in the estimate model is not correlated with all the explanatory variables. Since epsilon is a composite error term that can be written as a function of the error in the true model mu and the error in the Proxy variable equation nu3. The no correlation assumption implies that both mu and nu3 are uncorrelated with all the explanatory variables. Under this assumption, the OLS estimators alpha 1 hat and alpha 2 hat in the estimated model are consistent estimators for the population parameters beta 1 and beta 2 in the true model. This method is known as the Proxy variable method, or the plug-in solution to the omitted variable bias. The idea behind the Proxy variable method is that we hope the Proxy variable represents the variation in the omitted variable. After controlling for the Proxy variable in the model, the remaining variation in the omitted variable will not be correlated with the explanatory variables in the model. Therefore, the OLS estimators are unbiased and consistent, and the omitted variable bias is eliminated. Since x1 and x2 do not appear in the Proxy variable equation, this indicates if this is not the case, the Proxy variable equation is as follows. After parceling out the effect of the Proxy variable x3, the omitted variable x3 star is still correlated with x1 and x2. In this situation, the x3 is not a perfect Proxy variable for x3 star. We can show that using the Proxy variable method cannot eliminate the omitted variable bias. The OLS estimator alpha 1 hat and alpha 2 hat in the estimated model will be biased or inconsistent for the population parameters beta 1 and beta 2. This model uses education, work experience, tenure with the current employer, marital status, whether living in the South, whether living in urban areas, and race to explain monthly earnings. A well-known challenge in estimating the return to education in the model is how to control for the unobserved ability. Because ability affects workers' earnings and is also related to educational attainment, omitting it will bias the OLS estimate of the return to education. One possible solution is using the IQ scores as a Proxy variable for the unobserved ability. We can use data's summarize command to find information about the education variable and the IQ variable. I estimate the model using the OLS method with and without the Proxy variable IQ and compare the estimates in the table. After controlling for unobserved ability by the Proxy variable method, the estimated return to education drops from 6.5% to 5.4%. We could use more than one Proxy variable for one omitted variable. Another variable in the sample is the score on the KWW test, which is also a measure of ability. If we use both the IQ scores and the KWW scores as Proxy variables for the unobserved ability, the estimated return to education falls to 5%. The return to education is very statistically significant. The p-values from all the models are below 0.1%. In the model with IQ and KWW as Proxy variables for ability, both the scores are individually and jointly statistically significant. KWW is individually significant at the 5% level. IQ is individually significant at the 1% level. They are jointly significant at any significance levels above 0.02%. Today, we discussed the Proxy variable method to alleviate the omitted variable problem. The Proxy variable is a variable that we can collect data on, and it is correlated with the omitted variable. We plug the Proxy variable in the place of the omitted variable and use the Proxy variable to account for the variation in the omitted variable. If the remaining variation in the omitted variable after parceling out the effect of the Proxy variable is not correlated with the explanatory variables in the model, then the OLS estimators are unbiased and consistent. On the contrary, if the variation in the omitted variable after we have parceled out the effect of the Proxy variable remains correlated with the explanatory variables in the model, the OLS estimators remain inconsistent under the Proxy variable method. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.